Assalamualaikum warahmatullahi wabarakatuh. My name is Amin Syuhada binti Aminuddin and my matric number is 214988. So today I will be presenting about my final year project with the topic of designing DNA aptamers for the detection of CP1 and CP2 proteins of rice tunggal cervical virus. So rice tunggal cervical virus or RTSV is one of the viruses that are responsible for rice tunggal disease, which is a serious threat to rice cultivation in Southeast Asia. This disease affects the Oryza sativa, which is rice plant. And in terms of infection, this rice tunggal cervical virus works synergistically with rice tunggal bacilliform virus and transmitted through vector called nephrotic bacillus, which is green leaf hopper. So this infection caused an estimated annual loss of approximately 1.5 billion US dollar in rice production globally. So for detection of these viruses, conventional method like RT-PCR and ELISA is used, but they have limitation like time consuming, expensive in terms of the equipments, and still depend on unstable antibody. Therefore, other method which is much faster, cost-effective, and stable is needed. So, a promising alternative is a DNA aptamer-based detection method, which formed the core focus of my final year project. Next, for objective, the first one is to identify the target site of RTSV's code protein CP1 and CP2. Number 2 is to design DNA aptamers targeting RTSV code protein CP1 and CP2. And number 3 is to study aptamer protein interaction in terms of binding, affinity, and energy. So, next, methodology. There are 4 steps that involve in methodology. The first one is to retrieving the amino acid sequences. So, UniProt databank is used to retrieve the amino acid sequence of code protein CP1 and CP2 and then paste into the AlphaFold tree to retrieve their 3D structure. And then visualize using Auto.Vina to prepare the target protein for molecular docking. And number 2 is structure prediction. In this step, I need to design the DNA aptamers for its 2D structure and 3D structure. For the first, I use the GTRNA-DB to retrieve its primary sequence, and then the primary sequence will be copy and paste into the RNA fold server to retrieve its 3D structure, and then using the RNA composer to retrieve its 3D structure, and then use PyMol tools to visualize the 3D structure. And then number 3 is molecular docking to visualize the aptamer and the target protein complex. So I use Auto.Vina and Z.Server, but I more prefer Auto.Vina because it can give the binding affinity and energy of the target protein and aptamer complex. And then will be visualized using Chimera X and Visual Chimera X, and it will also give the binding, the hydrogen bond, and also hydrophobic interaction of the aptamer target protein complex. Lastly, is molecular dynamic using GROMACS. In these steps, the best aptamer protein complex will use, and the parameters such as root mean square deviation, root mean square fluctuation, and binding energy will be calculated to assess the interaction strength and structural consistency. Next, move on to the expected outcome. So I expect in this project is to identify a highly specific and stable DNA aptamer that bind to CP1 and CP2. And number 2 is to obtain the binding affinity and energy data to support the aptamer potential as a diagnostic tool. So this project is significant because it aligns with the Sustainable Development Goal, for example, zero hunger, which protecting the rice crops. And number 3, SDG 3 is good health and well-being because it supports disease control through early detection. So that's all from me. Thank you.